As data traffic skyrockets, traditional networks struggle to keep up. Reconfigurable networks, enabled by optical switching, provide the agility needed to stay ahead. Now, researchers are exploring groundbreaking ways to revolutionize data center operations. Join us as we speak with Chen, Avin, and Stefan Schmid to discuss revolutionizing data center networks via reconfigurable topologies.
The goal of our paper is to provide a comprehensive overview of reconfigurable data center networks, RDCNs, and we want to show how a dynamically changing topology can overcome the limitation of static fixed topologies networks. Our paper actually is based on two main observations. The first observation is that data center networks have become a critical infrastructure for our digital society. And the second observation is that the current solution that based on static fixed topologies lead to inefficiency.
So the proposed solution we discuss are reconfigurable data center networks, or RDCNs, that are based on optical switching technologies that allow to change the topology in a dynamic manner. And this can either be in a demand-aware or in a demand-oblivious fashion. And if you do that, you can reduce path lengths and improve bandwidth efficiency of the data center network.
A main issue when dealing with data centers and networks is how we interconnect the computing units, like servers or GPUs.
What's common to the current solution that they all use fixed and demand-oblivious topology. You can think of it as a highway that ignores the traffic, and this could lead to a lot of frustration, like as we see in the picture that we don't use the highway in the correct way. It was really cool if we could add more lanes during rush hours. RDCN, or Reconfigurable Data Center Network, come to solve exactly this problem using optical technology. When a new demand matrix arrives, we can reconfigure the circuit and the topology to match exactly the demand.
So to realize reconfigurable data center networks, one way to do is that you connect top-of-the-rack switches to an optical circuit switch, and the switch can then dynamically change the interconnect inside. And there are different technologies to do that. You can use, for example, digital mirroring devices or tunable lasers. You have these three racks connected to the optical circuit switch. If the light is coming here on port number 3, then it's reflected on the mirror inside the optical circuit switch like this, and it's reflected again on the mirror there and goes out to rack number 1 and establishing this connection between 1 and 3. Now, if you would turn the mirror in the optical switch, then if the light comes again on port 3, it will go to that place at the mirror and be reflected like this. And now it's exiting directly to rack number 2. So you have established a connection between rack 2 and rack 3.
We discuss in the paper the motivation, the technological enablers, a taxonomy of different types of networks, a model, and open challenges for the community. The thing that I'm most excited about is that I believe that RDCN are here to stay. And the research combined areas that I love, like theory, networking, and practical problems that make a big difference.
Find out more in Revolutionizing Data Center Networks via Reconfigurable Topologies, a research article in the June 2025 Communications of the ACM.